Hi there, welcome to my YouTube channel, Prime Maths. In this video, I will be dealing with the problem of definite integral here. N is given to be a positive integer, and fx is defined as minimum of mod x minus 1, mod x minus 2, mod x minus 3, till mod x minus n. For this function, we have to integrate from 0 to n plus 1. This problem has to do more with finding the minimum for x in specific range, as you will say the integration part is straightforward once we split the integral properly. So let's start solving. Before proceeding into solving the problem, first take a look at the function given. If we take the value of n to be 10, then for this problem x ranges from 0 to 11. If we take x to be 0.5, then fx is minimum of mod 0.5 minus 1, mod 0.5 minus 2, mod 0.5 minus 3, till mod 0.5 minus 10. The values after subtracting and taking the modes are 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, 8.5, 9.5. Among these the minimum is 0.5, so f of 0.5 is 0.5. Now if we take x to be 2.7, then fx is minimum of mod 2.7 minus 1, mod 2.7 minus 2, mod 2.7 minus 3, till mod 2.7 minus 10. The values after subtracting and taking modes are 1.7, 0.7, 0.3, 1.3, 2.3, 3.3, 4.3, 5.3, 6.3, 7.3. Among these the minimum is 0.3, so f of 2.7 is 0.3. Next we will try to understand what fx is giving for a given x, using diagrams of number line. Now to understand what the function fx is computing for a given x, we take the case discussed earlier. Here n is 10, therefore x ranges from 0 to 11. We plot the points 1 to 10 on the number line, and then mark a point x, say, between 5 and 6, as shown in the diagram. Then for this x, mod of x minus 1 is nothing but the distance between the points x and 1. Similarly for the points 2, 3, 4, 5, 6, 7, 8, 9, and 10, the respective distances are marked as you can see. Now, fx is nothing but minimum of these distances. As one can see, for this particular x, which lies between 5 and 6, the point from x, which will be nearer to it, is 5 or 6, as other distances are clearly greater than these two distances. As we have shown that fx computes the minimum distance of the point x, form the points 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, for the example we are exploring. Now, if you see the diagram, then is clear that, for all x lying between 0 and 1.5, fx will be simply mod of x minus 1, as all the integer points from 2 till 10 have larger distances compared to the point 1. Next, similarly for all the points between 1.5, 2, 2.5, fx will be mod of x minus 2, as 2 is the nearest integer points from 1 to 10, for all x lying between 1.5, 2, 2.5. Similarly, the intervals are divided in such a way, such that for any x, we can easily get fx. Lastly, see that, for any x, between 9.5 to 11, the nearest integer point is 10. With these points in mind, we can now split the integral for any n in such a way, such that fx is easily calculated, which we will do now. So now we split the original integral from 0 to n plus 1 by considering the intervals 0 to 1½ 1½ to 2½ 2½ to 3½ till n-2½ to n-1½ and the last interval is from n-1½ to n+1. Note that we have in total n integrals, since we have divided the interval from 0 to n+1 in n subintervals. You can go back and see and compare with the case where n is 10. Leaving the first and the last integral, we have two integrals in total. Next, we put the values of f(x) as mod x minus k, where k is the kth subinterval. Now, we have to simply solve these simple integrals, involving mod sign. Now, we simply integrate each of the integrals to get the final answer, which you can see on your screen. I have not shown the calculations, you can compute it easily. The values of all the integrals, except the last and the first one, is 1/4, while those two have 5/8. If you don't know to calculate integrals with mod sign, you can comment for help. If you find the video useful, don't forget to hit like, share and subscribe. Any suggestion and comment will be welcomed. You can follow us on Instagram and Facebook at Prime Maths. Thanks for watching.